Hello students, in this video we discuss effect of temperature on equilibrium constant. Effect of temperature on equilibrium constant is explained based on Van 't Hoff equation. Van 't Hoff equation. The equation is log K2 by K1 equal to delta H by 2.303 R into 1 by T1 minus 1 by T2. Here the T1 is the absolute temperature. At that temperature, the equilibrium constant is K1. At T2 temperature, the equilibrium constant is K2. And delta H is heat of the reaction. Heat of reaction at constant volume. So at T1 and T2 temperature, and which equilibrium constant is more, that how to find out. That is depends upon the delta H as well as the temperatures. So case 1, delta H is equal to 0. So that means there is no absorption of heat and liberation of the heat. So this term is equal to the 0. Delta H is equal to 0. This total term is equal to 0. Therefore, log K2 by K1 is equal to 0. From this one, K2 by K1 is equal to anti-log of 0 is equal to 1. So that is K1 is equal to K2. K1 is equal to the K2. So at all temperatures, equilibrium constant is constant. Equilibrium constant is constant. If delta H is equal to 0. Case 2, delta H is equal to negative. So the equilibrium reaction is present at forward reaction is a exothermic process. Log K2 by K1 equal to, this is the delta minus delta H by 2.303 R into 1 by T1 minus 1 by T2. So in this one, T2 is greater than T1. Temperature is increases. If the temperature is increases, then log K2 by K1, is equal to, this term is equal to the positive value, the total value will get the negative value. So log K2 by K1 is log K2 minus log K1 equal to negative. For getting of the negative value, K1 is greater than the K2. So K1 is greater than K2. If the temperature is increases, the reaction is exothermic process. Reaction is the exothermic process. If the temperature is increases, T1 equilibrium constant at lower temperature is more than the higher temperature. In case T2 is less than the T1. Temperature is decreases. Log K2 by K1 is equal to positive value. So this value will get the negative. Negative into negative is the positive. Log K2 minus log K1 is equal to positive. For getting of the positive value, K2 is greater than K1. K2 is greater than K1. For exothermic reaction, the temperature is decreases. At that condition, the K2 is greater than the K1. And case 3, delta H is equal to positive. That is endothermic. So you know the equation log K2 by K1 is equal to delta H by 2.303 into R into 1 by T1 minus 1 by T2. Case 1. In this one, first one, T2 is greater than T1. Temperature is increases. This total term will get the positive value. And log K2 by K1 is also the positive. Log K2 by K1 is equal to log K2 minus log K1 equal to positive. For getting of positive, K2 is greater than. So that means as the temperature is increases, the equilibrium constant is also increases. K2 is greater than K1. And the second condition, if the temperature is decreases, T2 is less than the T1, then log K2 by K1 is equal to negative value. So this term is negative, delta H is positive, so the total term is exhibit negative value. Log K2 minus log K1 is equal to negative. So in this condition, K1 is greater than the K2. So the equilibrium constant is decreases. When the temperature is decreases, the equilibrium constant is also decreases in the case of endothermic reaction. Thank you. For more updates, please subscribe my channel.